I'm making this video just to talk about the Valentine's Day weekend storm system. And I just want to go over what the models are showing because it's very interesting. There's a lot of pieces that are going to be coming together for this storm. And it's very uncertain at this point as to the exact track that this storm is going to take. But I do believe that there is going to be a reinforcement shot of cold air ahead of this system. It's not going to be nearly as strong as the last one when we had that major winter storm that brought a huge area of snow and freezing rain and sleet across a large portion of the U.S. But we are going to have enough cold air in place for a region of snow depending on the track that this storm takes. I'm going to show you there's three scenarios, but I'm going to show you the graphics that I made for two of the scenarios, and I'll talk about the third then right after. So obviously scenario number one is that the storm tracks northward up and along the East Coast and brings that region of snow across a portion of the mid-Atlantic into the Appalachian Mountain Range, across the New England and the Northeast region, with rain being across the southeast and south central U.S. all the way from Texas to the East Coast. That's scenario number one. Now, scenario number two is it's a flatter wave, meaning that the northern piece, and I'll show you on the models, but the northern piece is not as strong, so it doesn't guide that storm up the coast. So the storm stays suppressed to the south, and you get rain across the south central and the southeastern U.S., including some thunderstorms possibly. But you don't get a region of snow because the cold air is going to be further northward. You're not going to have that large of a cold air supply that south. So if it stays suppressed to the south, we don't see snow out of this. I don't see a snow threat across the southeast. I know I saw on social media the other day someone sharing about one model run showing snow across northern Georgia and into South Carolina. I don't see that being a possibility. The cold air is not going to be that far south. It's not going to be that abundant down there. So that's scenario number three, is a mix in between scenario one, scenario two. And I'll show you what I mean by that when I show you the models, but let's take a look at the models now. So we're going to start with the Euro. This is actually the GFS model. We're going to start with the GFS here, and I want to show you this. This is the one piece of energy. This is the other piece of energy. This is going to dive south around the base of that trough, and then this energy is going to drop into that energy when it's down here, and it's going to traverse the country, and I'll show you here what I mean by that. See that energy? It's coming down, surrounding the base. That energy across California drops south into that piece of energy, and then you get this trough here, and it's a positively tilted trough across the south central United States, and this is Saturday at 10 p.m. Saturday at 10 p.m. Eastern Daylight Time. And look at this. The northern piece is not that strong. It does not dig that far south. Look at the isobars. They're flat. They're zonal flow. You don't get that. And I'll show you what I mean. Let's take a look at the Euro at the same time. Here we go. Look at that. You see that trough here? The northern piece is digging further south. You see that? See the kinks in the isobars up here? The northern piece is stronger. It digs south, and it guides this storm further northward, whereas the GFS, and I'm going to show you the GFS again. Look at this. You don't have that. It's not nearly as strong. The trough is not as strong. It's a broader trough, and the northern piece is not as strong, so it doesn't guide that storm up the coast. So it's a flatter wave, and it's suppressed to the south. And look where it goes. Out to sea. And I want to zoom in here. I want to show you the surface depiction because that's important too. So here's our storm system across the southeast, and look where it goes. You get the GFS brings some light snow across southeastern PA, and I think that's a stretch. I think this storm would stay more suppressed to the south. I don't think you'd get much precipitation up here, but that's what the GFS is showing, and it takes it straight out to sea. Now I want to show you the difference between the European model and the GFS. Let's move to the European model now. So here's the European model. Here's our energy. That's going to bring the storm. And take a look at this. I'm going to move this along here. And look at these kinks in the isobars. You get that northern piece. The northern piece is stronger. It digs south. And it guides this storm up and along the coast. And then look at this. You get a negatively tilted trough here. And you get that storm. You get the south and southeasterly flow out ahead of the trough. And that guides the storm up and along the coast, and it throws that precipitation back into the cold air, which, let's look at the surface here. I'm going to show you where the 540 line is. And like I've said it before, and I'll say it again, 540 line is precisely where it's what we use as the rain and snow line. And look where it is. It's right up and along here. So you get a good snow across the Northeast and the New England region with this solution if it comes up and along the coast, because you are going to have a shot of cold air ahead of this system. Like I said, not Arctic air. It's cold enough to support snow if you get the storm system to move far enough north. But look at that. If the storm system is down here, let's just look at the GFS just to show you what I mean. Look at the GFS. Look where that 540 line is. It's up here in Pennsylvania. You ain't getting snow out of that down here in the southeast. So I don't know why people were sharing that one model run showing snow across the southeast, because that ain't going to happen. It was one model run that showed that. And it honestly, you could have almost thrown that out right after seeing it, because it just did not make sense for the conditions that we were going to be having, because we weren't going to have Arctic air, and there wasn't going to be a cold shot bringing cold air that far south ahead of this storm system. So the reason why they shared that beats me. I really don't understand it. Now I want to show you one more thing. I'm going to show you the Euro AI, because the Euro AI has been fairly consistent over the last few runs of showing where the storm is going to go. And the Euro AI has been, I'll tell you right now, it has been fairly good this winter with these storms. I'm not saying it's going to be right, but if I had to put money on one of the models, Euro AI would probably, if I was a betting man, Euro AI would be the one that I would bet the money on. Let's take a look at that real quick. Here's the Euro AI. Here's the 500 millibar and vorticity map. And look at this. The northern piece is not strong. It does not dig south. It does not guide this storm up the coast. So you get a flatter wave here. And look where it goes. Out to sea. And show you the surface here too. Show you what it looks like at the surface. Looks similar to the GFS, but it keeps that precipitation further south, suppressed to the south. And look where the 540 line is. Up here in Pennsylvania. You don't get snow out of that in the southeast. And I said it already, but I tend to believe the Euro AI. I put more weight in the Euro AI, at least after this winter, than I do in the operational models. And it's been fairly consistent. Let me show you this is the 18Z run. So that was 1 p.m. today. Let's show you the morning run. Look at that. Similar. Look how similar that is. Let's show you, this is the 1 a.m. run. A little bit further north, but it still has that similar idea. Keeps it suppressed to the south. And look how far north that 540 line is. It is still across Pennsylvania. You don't get snow out of that in the southeast. Take a look at last night's run. Suppressed to the south. It keeps everything below the Pennsylvania-Maryland border. That's why I think the GFS is overdoing. I think the GFS has the right idea on this one. I really do. I don't think, I could be wrong, but I want to tell you, I don't think that this storm is going to come up the coast. I really don't. I could be wrong, but that's just, I'm giving you my best thoughts right now. And that's what meteorologists are supposed to do. They're supposed to put themselves out there. If I'm wrong, I'm wrong, and I'll try better on the next one, and I'll try to learn from my mistakes. But I really don't think that this, I'm leaning towards either a scenario 2 or scenario 3, which would be a mix of scenario 1 and scenario 2. I'm going to show you what the Canadian model is showing too while I'm at it. While we're going at it, let's show you what the Canadian model is showing. I'm just going to show you the surface. Let me switch to so you can see the different colors here between rain and snow. I like this. Canadian brings it a little bit further north, but it's kind of a mix still in between scenario 1 and scenario 2. Still think it's overdoing it in the northern extent of the precipitation, but it remains to be seen. So stay tuned. I'll keep you guys updated. If anything changes, I'll let you guys know. Thank you guys for watching. Hope you guys enjoyed. Make sure to follow me on X and on Facebook at Geostrophic Flow. And thank you guys for watching.